All right. So as we head towards the end of the semester, we get into really, really interesting different types of technologies. And I think one of the most interesting that students tend to like is constructed wetlands. So this is kind of an interesting technology that uses kind of biomimicry principles where we mimic what happens in the natural environment. And so it's a very kind of sought after technology from an environmental standpoint, and environmental engineering. So constructed wetlands tend to be either a secondary or tertiary treatment process. So there's some removal of biological components in a constructed wetland. A lot of their open water surfaces function very similarly to a stabilization pond or an aeration lagoon. But they're also great for tertiary treatment. So they're great for stabilization of biological components that maybe we just couldn't remove in activated sludge, or maybe we don't have activated sludge, and so it serves as secondary treatment. But it's also good for nutrient removal. So it very naturally mimics kind of plant life and wetland processes. And so it's really good for removal of nitrogen and phosphorus. So it's both secondary and potentially tertiary treatment in your system. So the idea with a constructed wetland is that we use vegetation planted in a basin or a pond for specific treatment of effluent. So we're actually planting and seeding these wetlands, and we're using specific types of plant species. And those plant species in their root system and in their actual biological structure are able to utilize a lot of the components that are in wastewater, particularly nutrients. So that's really kind of an interesting process where we just mimic what happens in the natural environment, because this happens in marshes and lagoons and wetlands in the environment, in the natural world. So they are predominantly biological treatment systems. We remove and transform pollutants, and we typically kill off a lot of pathogens in these systems, or they get inactivated. We have in this system potentially, flies, maybe we have insects and other predators that will eat microorganisms or pathogens. So we actually utilize that as a way to remove pathogens from a system. It's kind of interesting. And so they have some ancillary benefits as well. So not only are we cleaning wastewater at this point, but there's little to no energy consumption, limited chemical use, and it can actually be a wildlife habitat. And so it's very aesthetically pleasing many times to have a constructed wetland because it's nice to look at in the kind of environment where you are. So there's a couple different types of constructed wetlands, and I want to talk about them in the pre-lecture so that we can focus on designing them in lecture itself. But we can have what's called a free water surface wetland, a FWS, or we can have a vegetated submerged bed wetland, so a VSB system. So basically, it's the difference between horizontal or vertical flow potentially in the system. And we typically see vertical flow subsurface wetlands used to treat higher strength waters, wastewaters that are coming in. And we typically see the free water surface wetlands. That's the kind of wetland that you think about when you think about a wetland, where you have open water surface. That tends to be, that acts a little bit more like a stabilization pond, whereas we get a little bit more targeted removal of nutrients in a vertical submerged bed. We typically see the free water surface wetlands in larger wastewater systems, and we typically see the VSB wetlands in smaller on-site applications. So if you're doing a very small wetland design, typically we see a vegetated submerged bed wetland. So when we talk about types of constructed wetlands, we talk about kind of the difference between how they're operated, their common treatment applications, the typical influent that comes into them, so on and so forth. So we have three different types. We have two that flow horizontally and one that could potentially flow vertically. So the one that flows vertically acts more like a filter. The ones that flow horizontally tend to act more like ponds or stabilization ponds or aerated lagoons. And what you'll see here is that we can treat things like stormwater, mine runoff, groundwater with some of these wetlands, which is not something that we've talked about with other types of treatment so far. They're great for domestic wastewaters as well, but we can also kind of get these ancillary, tertiary treatment benefits. And then what's kind of interesting, let me grab my laser pointer. We have this attraction for wildlife characteristics. So, I mean, we're going to get things like insects, fish, amphibians, reptiles, all sorts of interesting creatures are going to come and live in our wetlands, which is kind of an interesting feature when you think about wastewater treatment. So that's kind of an interesting thing that we might want to think about when we're putting together a wetland design. So how do they work? So typically when we have a free wetland, kind of the free water surface wetland, the FWS, the water surface is visible and flow is typically horizontal. We normally have gravel beds at the bottom, which are about a foot deep. And then the top of that gravel bed is about 2 to 4 feet below the water surface. So it kind of looks like a lake in many ways. And it's typically used to treat larger flows. And normally the types of plant that we have are floating plants. So they're normally not planted in the gravel, they normally float on the top. So we can use algal species, we can use lily pads, things like that. And the goal is to try and get really good tertiary effluent. So it's almost ready to go to a receiving body. In the vegetated subsurface bed, we typically have gravel at the bottom and the water's moving through it. The gravel is typically a little bit deeper in these systems. It typically treats smaller flows, and the idea is that we're going to have a surface on top of that gravel where we plant our plants, and the plant root systems are part of what's going to be really important in these wetlands. And normally here we're only looking for secondary treatment with these types of systems, so they tend to again be a little bit more of a biological treatment type of system. So here's just a kind of quick look at 2 different types. So you can see with the free water surface, you can see that water surface actually in it. And with the submerged bed wetland, you can't actually see that free water surface. So both of these kind of occur naturally in the natural environment, and we're using them to mimic, we use them in wastewater to try and get the same types of cycling of nutrients that we see in the real world. What you'll see on the bottom is just kind of an example of an overall wetland. It's kind of a conglomerate of the two. It's a little bit closer to the VSB system. And so you'll see the water comes in, it hits some gravel, and that gravel is just going to do a little bit of filtration. And then we're going to have wetland plants here, some smaller gravel, a liner so things don't escape. And then our effluent is coming out the far side. So, key concepts in a wetland. We have lots of different treatment processes happening. So, don't think of a wetland so much as a reactor. Think of it as an ecosystem. So, many things are happening in a constructed wetland all at the same time. So, we get biodegradable organics degrading. So, we get substrate utilization just like we do in organic biodigesters that we've talked about previously. We get suspended solids removal by filtration and by sedimentation. So having all that sand and that gravel is actually natural filtration. We get nitrogen and phosphorus removal because plants like those nutrients, and so they uptake those nutrients. We can also get some adsorption of trace organics and heavy metals. And then we can also get removal of pathogens, but just by the fact that they're decaying in the system. These systems are also outdoors, so we have natural sunlight, so we get a little bit of natural UV disinfection. And then we also have predation, so there's other organisms that are going to live in a wetland that are going to eat these pathogens, and then we get rid of them that way, and so we don't have to add chemicals. So lots of things happen in a wetland. You want to think of it as an ecosystem, not a reactor. So some key components, these are the 2 different types of wetlands we've been talking about so far in this lecture. You have an inlet on both that is typically right around the ground surface. You have some kind of a media, and you have a liner at the bottom, so you have what's called an impermeable liner because you want to keep the wetland where it needs to be. And generally you have gravel and sand to kind of bed those plants and make them very useful for filtration. you have some types of vegetation in your system, and then you typically have some kind of a control that controls the effluent out of the system. So those are the key components. So some parameters that you need to know when it comes to designing wetland, much like we've been talking about with almost everything with wastewater, you need to know influent BOD, but nitrogen and phosphorus are also going to be really important in these particular systems. You're going to need to know things like plant growth, biomass, their depth, and their rooting, so you have to become a little bit of a botanist when you do constructed wetlands, because you do actually have to know how these plants are going to grow and whether or not they're going to survive in the wetland long term. That's important. You have to know the depth of your media, the water column depth, and then you have to know DO as well in these systems. So a lot of the same parameters that we've seen before, but now you add that element of living plants that you want to keep living in your system as well. Some key calculations, area and volume of each of the chambers. So many times wetlands have multiple stages that we'll talk about in class. Less of a calculation, more of a design consideration is the type of plants used for removal. So you can actually choose specific plants for specific types of removal. So less of a design calculation, more of a design decision. We need to think about effective hydraulic conductivity, our number of zones, and our depth of our zones. So much like a stabilization pond, how deep it is and how fast water is moving through it is really going to be the key thing in constructed wetlands. And then we'll finish off with some advantages and disadvantages. So much like our stabilization ponds, it's a passive treatment and it mimics a lot of biological things that are happening in the natural world. And I think that's one of the key advantages of wetlands that people are really interested in. The fact that you have all of these things happening that happen in the real world and that are very natural. It also restores natural habitats for wildlife. So if you can build a wetland, that's a great thing for community, cultural kind of implications in a community. And it's better to look at, honestly, than a big sludge processing plant. And then it has those ancillary benefits of nutrient removal. And sometimes that is the biggest benefit of a wetland, is that nutrient removal. Some disadvantages, much like your ponds, you can have a very, very large amount of land to try and treat very targeted parameters, especially if you're looking at very specialized wastewaters like mine drainage or stormwaters. You may actually need quite a bit of land in order to get the removal that's necessary for whatever your wastewater is. And then if the system is not operating effectively, maintenance can be a little different. Normally maintenance is very hands-off in a constructed wetland, but if things are dying in your system, you have to dig the whole thing up many times. And so maintenance and kind of keeping it where it needs to be is a really important parameter for constructed wetlands. So in class, we'll talk a little bit about how to design these specifically, but hopefully this gives you a little bit of a primer on what these technologies look like.